All. Good evening to all. This is the fourth session of live interaction. So in this session we are going to discuss about stacks. So we're going to touch the basic concepts of stack and how to create a stack using Java, and we will solve one question related to this using the stack that we have created in the same program, this in the Java. So we're going to see that in this 1 hour. So stack is a data structures which programmer use for solving multiple types of problems, and the concept of stack is very clear. It's last in first out. That means consider a stack of plates. If you put stack of your plates on top of each other, so the last plate which you have put is the first plate that you're going to take out. You can't take out the first plate that you have taken put there, because that will be in the last. So that is last and first out. The last element which you are entering the data structure is the first element that you have to take it out, and it can be implemented using two ways: arrays and linked lists. Today we are going to touch only upon the array part. Okay, now is my voice is clear? If I am speaking if it is showing like that, okay, yeah, it's clear. Okay. Okay, so to give a understanding of how stack works is, instead of telling how we put numbers on the stack, I will try to give you a real based scenario of how actually we used to use stack in our operating system. So whenever you write programs also, you might have wrote multiple functions and you calling them at different point of time. So how the stack are used in that point of time. So let's see that. So these are three functions are there, which is int main. This is function called a and b. So obviously every program is going to start from main function. From main function it will call, as you can see here, as you can see here, it's calling b. So it's going to call b. Then from calling b, it's doing something, a b function, it's calling a, and it's again doing something. So once the function is done with its statement, it will come back to b and it will come back to main to end the program. So how operating system usually store this information, how the compiler or the operating system know that this is the way that how the program should work. So what we use the stack as a leaf for, that is last and first point. So it will always start at the bottom. So that's a stack pointer. So in this there are two concepts will come into share everywhere, like how you enter something in the data structure and how you take out something from data structure. So it's quite common in every data structure you find out. So in stacks, particularly when we put something on the stack data structure, it's called push. Whenever we take out something out of it, we call it pop. So let's take the earlier example and see how it is actually storing the stack, and this is a real case scenario which is actually used in your operating system. So first, main function is there. Every program start from main function, so it will put main and the stack pointer. So it will push the main function in the stack. Then it will, since calling b, so it is pushing b in the stack. Then since from b it's calling a, so it is pushing a in the stack. So once the a function has been done with its functionality, we will take out, that is we are popping it out from the stack. That's what we are doing, pop. So again the stack pointer, if you can observe, it is went back to b. So after a, if some other statements are written in the b function, it will execute. Then once b is completed, it will see some statements are written from in main function, it will execute, and then it will do it. So that's how the main stack functionality works in real case scenario as well. So what now we are going to do here is we will see how in Java we are going to execute this thing mostly through arrays. So we are going to create a data structures using arrays as part of it. So stacks are basically our user defined one. So here arrays are something which is built in data structure you will find. but using the built-in array structures, you're creating stacks, queues, circular queues, linked list. All these things will come into picture, which eventually you're going to see over the period of time in the course as well. So let's go to the Eclipse. Let's see whether it's showing that or not. Can anyone see my Eclipse screen? Okay, no. Okay, fine. So what should I do? It came. Okay, yeah. Okay, so now I have already created a Java file, so in which stack I'm naming it as stack implementation, and I have a main function with respect to it. So what we have to do is we are going to use Java to create create a stack data structures. So what I'm going to do is here I will take a little different approach. Usually what happens in a basically data while coding in a class, what people usually do is they will create some variables, or you can say they can get some variables, they will create some methods, and then they will try to execute from main function. That's a basic approach which everyone follows. But now here, instead of using public class for creating variable methods, we are going to create a class for stack itself, and then we are going to define everything in this class, and then we use main method to execute the functionality of the stack array. So what are the functionalities of stack? As we have discussed, there is something called push, that is enter the element in the stack. We have this push operation, we have pop operation, that is remove the element from the stack. Then and some basic operations that print, that is to see current state of the stack. There is something called a stop. So if you have observed here in this, there is something called a stack pointer. This stack pointer is quite much important for us to know that where actually we are at the which point of the time we are in the stack. So stack, since eventually it's an array, we are making through it array, so we should know that which part of stack it's currently pointing to. So we should know this top function as well. So top element, or the recent element or the current state of the stack. And then we can after this we have to identify that whether the stack is full or not. This is full or not, this is one thing. Or we have to check stack if it is empty or not. So we're going to code each and every aspect of it right now. Okay, so let's start with this. So we will start, I'm not going to touch right now any main function, right, because we are going to execute it over the period of time, but we will start with making methods which related to the stack using which use arrays and whatever the variables we need for that. So first is in top. I am using this top. I will explain more in the next few minutes what what exactly it means. Max is I'm giving the size of the stack. Here I am making 5 for now. We can change it based on the user input over the period of time. Again, now I have to declare an array for which new int. This is how you declare an array. So I int what name of the array, and then I have to use new keyword to give this new keyword int, and I have to give the size of the array. So I am declaring the array here. Okay, so this is the 3 variables which we need. Only these 3 variables needed to create a basic structure of the stack. So first we have to see how to enter an element in the stack, that is push operation. So what I am doing is I am creating a public function. I hope by this time you might know public, what is public. It's an access modifier. So I am creating an function. I am taking some values which is going to provide by the users to put in the stack. So what I am going to see is first, so this top is when I am saying right now. So this top is act as a pointer or as a pointer to stack, not exactly the pointer, or just say that which tell me the tell at which position we can that stack is currently in. Okay, it may tell me the position, whether I can put some element or not, whether it's totally empty, or if you want to enter any element at that point of time, how should I put an element. So it acts as some kind of reference to me, the top, which can help me to identify the stuff. So what I have to do is, whenever I am getting some variable, I have to increase the values of top. Usually start at 0. That's a by default, because in array everything start with a 0 index. So what we say, whenever a value has to be put, I will put top plus plus. So it at the top position I will put the value, whatever the value is given by the user. That is thing. But what if I'm putting the I'm going to put some value in the stack, but if it is full, so we have to check some condition that check whether the stack is currently full or not. So what I will do, I have to create another function eventually which checks that whether the stack is currently full or not. So if it is full, then I have to return false, stating that I can't. Sorry, yeah. If it is full, then I have to say that I can't run it. Okay, so I have to put that thing. So I will write a statement like system.out.println stack is full. It's just a condition to check that whether the stack is full or not, and whether I can do something, whether I can add the element or not. So for this I have to create another function is full to check whether stack is empty or it's very full. So what I am going to do is, again I am to create another function public which returns boolean, and I will check is full. So in this I just have to check only one single thing, that is if top is equal to max, that is the size of an stack that we are providing, then you return true. Okay, otherwise if the top value is not equal to 5, you return as false. That means stack is still empty, and we still some space is left in stack, and then we can use it. We can still use it to put some values into it. That is one thing. So that's how we are checking the condition whether the stack is full or not. So this is so push is for entering an element, basically integer element that we are taking into the stack. Now second operation that we have to see here is pop. So okay, so second operation that we have to see is pop. That means to check whether I can remove an element from stack or not. Okay, so here I don't have to take any element, because here I can't take out any such element. I can take out the only element which is at the top of the stack. So for this, what I have to do is if I have to do something, I just have to return a value which is top minus 1. So what does it means is, if I have array which is 1 2 3 4 5, here 5 will be at the top of the stack. Okay, and if I, and the since the index is at the top, if I have to remove some element, I just have to take the index to 4. So what I'm doing, I'm just putting the pointer from 5 to 4, and whenever I need to add another new element at that point of time, it will if I do pop here, if I have to remove this, then the next element, say let's say 6, it will override the 5. So that's the basic logic of returning the thing to popping the element. We just taking out the element, moving the pointer from 5 to 4, such that whenever again when it comes to 5, it will override with the new value. Okay, but this is still not sufficient, because what if the stack is empty? Then you can't delete any element. So we have to keep on checking that whether the stack is empty or not. When we say stack empty, that means if the pointer of that stack is at the bottom. So if no value is there, it will be at the bottom. That means here in this case 1, it will be in the 1. So I can't delete any more than 1. So I have to check whether the stack is empty or not. For that, I have to create a function here which check is whether it's empty or not, whether stack is empty or not. If it is empty, then I have to system.println stack is empty. Otherwise, I will return a value which is not of arc consequences, that is some minimum value which doesn't have any significance, to tell that okay, you can't delete any more statement. Okay, so one question, why you write 6 there? So I was explaining the concept of pop here, that is removing an element. So suppose you have a stack of starting from 1, then 2, then 3, then 4 and 5. The 5 will be at the top of the stack. Now if I remove the I have to do the pop function, that I have to remove an element. The only thing that I have to do is, since the top is at 5, I just have to change from this index, I have to change the top into 4. I just have to change the index value, that's it. So once I do that, I will have only 4 elements in the stack instead of 5. So if I have to add new element, that is 6, what it will do, it just overwrite on top of 5. So it will remove the 5 and then make it 6 to create a new stack value, which is 1, 2, 3, 4 and 6. It just overwrite it. So that's why we are doing that. Okay, coming back to this, since we have to check that whether the stack is empty or not, we have to create another function to check it that. So I just copy paste from the boolean is full, because it's almost same. So I just have to check here is, if the value of top is equal to 0, that is at its initial value, I just have to return true, that it is actually empty. Otherwise, if it is not empty, I have to return false. So this is one thing, and so we have written 4 functions, that is pop, push, check whether the stack is full or not, whether stack is full or not, and here in empty I am checking whether the stack is empty or not. Okay, now another last function that I have to write here is public void print. So I just have to print out print the array, basically a stack which you are creating using array. So for int I equal to 0, I less than max, which is the size of an array, or you can say stack in this case, I will do it, and then system.out.println. Okay, I print and then println and a of I, that's it. Yeah, print of I, and then we have to just put an just for a few formatting thing, I'm just putting another sprint in. Okay, so yeah, we are done with this all the function. Now we're going to see how to implement it. So we have to execute it from the main function. So revise to get back to see what we have done. We have created a stack array, basic class, different class. In that we are defining the variables relevant to stack and methods related to stack. That is push, how to enter an element, pop, how to take out the element from the stack, is full to check that whether the stack is full, pop, is empty to check whether the stack is empty or not, and the print. These function have used. So now to use the stack, since it's a class, we have to create an object of it. So what we are going to do is we have to create an object. So I will create stack array element. The stack array is the class that we had taken, and then I'm creating an object for that. Okay, so this is the object which I will use and which represents stack actually. So the only thing that I have to do here is, now if I have to push an element to an array, pushing an element into the array or stack in this case, what I have to call, I just have to call an I just have to provide the value. So if I say element dot push, so what I'm using the object, and I'm using that, I'm calling a function called push, and I'm providing some passing some value through it. Okay, so we will use this. Since the value of stack size is 5, so we can max to max we can push 5 elements here. Okay, so and then we can print it out. We can see what is the value of the what is the value present in the stack. Okay, so to do that I will just change some values. 7, 8, 1. Okay, I'm just calling this function for now to see how it is working, whether it's working normally fine or not. Okay, so if you look like this, now I have done one mistake here. So if you look it as a stack, now the problem is it's showing that 10 is the top, 4, 7, 8, 1. So it is showing the order in which I pushed, but ideally in the stack, if you have seen, it should be 10 should be at the bottom and 1 should be at up. So what we can do max to max is we can start with max and max minus 1, and just we take it out 0. We will change some function, we will reverse an array and print it. So if we do it one more time, run. Okay, max cannot be resolved as a variable. I just have to change max minus 1. Okay. Okay, it's not printing. Let's see what's the problem. I have to do equal to 0. Okay, still it's not coming. So what is the problem? How I define max here? Oh, okay. It's max is 5. Int max, it's correct, perfectly fine. Int I equal to 0. Oh, I plus plus, instead of the I have to do I minus minus. That will work fine. Oh, still not working. Okay, what's the value? I have to make I greater than 0. Okay, now it's working fine. Thank you who have corrected me there. Okay, so now we can see that we start with 10. Okay, we push it as a first element. This is a first element and in the stack, but it will be actually, if in actual the concept wise, it will be in the last, in the bottom of the stack. Similarly, the one which enters the last element will be the last element. It will be even though it's entered last, but it will be the first of the stack. So now if I want to pop it out some element from there, and again if I print it out, so let's see what it will be there. Okay, element, okay, I am still okay. So instead of this I should go to top max best. Okay, so I have done one mistake here. So what I did, till print it's working everything fine. So when I am doing pop, ideally I should start with the value of the top, that is the pointer. So instead of 1, if I am doing, the pointer should come, the top pointer should come to 8. But it since I did the mistake in the coding there, that's why it is showing the 1875410. So if I run it again it's showing like that. Okay, so it just means I have some problem with the top. Okay, so what I have to do here is top -1. I have to top -1. That's it. I have to do this. I think it will work fine now. I have to reduce the value of top by -1, so that is what I have to do, but I didn't do that. So if I do this, now it is working fine. So what I did here is, when I pop the element, remove an element. So earlier it was 1. Now if I do this 8. So if I removing that again, if I remove again, so it will remove the 8 as well. So I will just copy paste this thing one more time, or maybe 2 more times. Let's see what will happen. Okay, so I added 187,410 as a stack. Then I removed 1 by pop operation, so it reduced to 4. Again pop, so it removed 8, so it came down to 3 elements in the stack. Now again I removed, so it came down to 2 elements in the stack. So if I remove again, and if I just do this, so I am removing this 3 more times, so see what will happen. Okay, so till here we have seen the last thing, that is we have 2 elements in the stack. If I do one more pop, what it will do, it will show the stack is empty, because I can't remove anything more than after 10. I can't remove anything much, so that's why we are removing this. Okay, this is one thing. Now let's take another example. So here till the last element we have element push 1. We have seen that I can include 5 elements. What if I add another element here? So let's say 3. Okay, I am adding it, so ideally it should show that stack is full. Okay, so if we show that, okay, so I should do this here as well. Okay, so what I have done is till 5 elements it is pushing very properly. After that, when I try to add 3, it is showing the stack is full. So again, if I since it is showing stack is full, it can't be entered in the stack. So that's why we again printed to show that this is how the stack will be still in the original tag. So even though I can't push that any element there, it will just show the message, and then it will just give it the whatever the earlier stack value as it is. Okay, so this is how we can do the basic of stack operations, that is which includes push, pull, and check whether the stack is empty or not as some condition to such that we can't take out any more element from the stack, or we can't take out anything element which are actually take out any element which is if it is not there. Okay, if we build stack, what will the default size? Okay, if you use inbuilt stack, that I think if you're using inbuilt stack, I think still you might have to define certain values for it. So I don't know how much it will be. max to max, it will, if it wants to go, it may go to the integer max value of integer. So that is one thing. Okay, so this is the basic stack operations that we have done in the first half. So I created a class for it. So again, when you're going to use inbuilt stack operation from the Java, which is already present there, you might not see the code, but this is how they might wrote the code as well. So there also they will ask for they will have a function name, maybe push or pop or print. Such kind of operation will be there. So we are using the same kind of settings in our implementation as well. Okay. Now, after this, we will use the same code again to solve one problem related to programming, completed programming problem, that is called parenthesis balance. Okay. So let's open that as well. Okay. So the balance parenthesis problem is simple. It's a very simple problem, but you use stack as a background. So what it says is, we have seen such kind of brackets in our programming or in any other context. Okay, this is called curly braces. This is called square brackets, and this is called parenthesis. Okay, so the problem of parenthesis is simple. It says that if I have a string, like, and it contains the balance, it contains some such kind of brackets in the strings. So we have to check that whether, okay, we have to check that whether it is whether combination of the those brackets are properly aligned or not. So what does it means is, so if you can see here, if I have a parent as a parenthesis, ideally I should have another closing parenthesis as well instead of curly braces. Okay, if I have a square bracket, so after inside the parenthesis, inside brackets are over, then I have to look at the outer brackets, like how in BODMAS you do, right? You expand, you start with the inner problem, and then you expand based on the how the parenthesis has been involved for the equation. So same concept. So we are checking that whether this square bracket has its closing at ending at the appropriate place or not, and then we will see again the curly braces, whether it has a proper curly braces at the end or not. So this is right now it's not balanced. The brackets are not balanced. So what is the balanced brackets would be? So if I am using parenthesis, it should be like this. Inside, if I write something as another brackets, I should have, so I should have square brackets. So if I use any curly braces here, so it should be like this. So you can see that the brackets are actually matching to each other. So the curly braces are matching to each other, and then you can see that the square bracket matches at each other with the appropriate place. That means if you use it in the math context also, you can use it properly because it is the brackets are placed appropriately. So this is a balance thing. So the question is to check that given a string which contains these kind of brackets, check whether the brackets are balanced or not. Okay, now this we can use it, we can solve it using stack. Okay, so how? So let's take this example of this balanced one. Okay, so what will happen is, if I create a stack here, so first I will take this opening parenthesis, so I will push that into the stack. Then This is the first element that I am pushing the stack. Okay, then if I encounter another opening of certain bracket, that in this case is square bracket, I will push into the stack. Similarly, any opening brackets, in this case is curly, I will push it to stack. Okay, now till now it is the role of stack is clear, but whenever you encounter any close bracket such that in this is closing curly braces, so you have to pop it out. The top element and check whether the closing brackets and opening brackets are similar or not. Okay, so here since when I pop it up, the open curly braces is at the top. So when I take it out and check that okay, the curly braces at this current element and the top element of the stack is same, so they are forming a balanced thing. Then if I now again I found that the square braces is there as a closing, so I will again pop it out the top element from the stack, pop element. So I found that there is a opening square bracket is there, so they are at the appropriate position, so they are still matching. Now if I again see that okay, the balance close parentheses are there, so again I will pop the element and I will see that okay, the opening parenthesis is at appropriate place with the closing parenthesis. So this is how the program will say that using stack that the given a string of and a pattern of brackets, it is a balanced one. So what if, how to identify it's not balanced one? So if you can observe the line number 8, instead of closing parenthesis, again if I put something curly braces instead of that, so here in the line 15th, the close it will be a curly braces. So when I am popping out the element, it is a open parenthesis, but the closing is actually given a curly braces. So ideally it will act as a false. So it will say that it's not balanced. So this is the background of the question that we are going to do using stack. Okay. Now how to do it with respect to it. So in this case, what we are going to do here is, here since it's a problem statement, I am going to use the functions that I have that we have created right now in the first 30 minutes of the session. Okay. Now in this, I have to define certain I have to define a function to check that particular string whether it's matching or not. So what I have to do here is, first we start with main function directly to get some understanding what we are saying. So as a string, I will get some input string. So here I can give certain kind of patterns. So here like I have given curly braces, square pattern, and then parenthesis. Okay, so I have given an input string like this, and ideally I know that this is a balanced one. So I want my program to identify that this is a balanced parenthesis. It should identify that it's perfectly balanced. Okay, so for this I will check. I will create a variable or object of balanced parenthesis, which is a class name. So I will use maybe b int use parenthesis. So I am creating an object of the same class. I will tell that why, and what I just need to do is I will create one function called check, and I will pass this input string str as an input to check that if it is returning the answer properly, I should put out the statement that input string plus input str is balanced. Okay, if it is not there, if it's not will check, I have to print it out, else I'll just copy paste here. Is input string is not balanced. Okay, so this is how the main function look like. We are just passing input string and we are calling a function called check, which we are going to define right now. So what we're going to define, we will define a function called check. I am giving as a returning function as boolean, just to give true and false. So it will just check that if it is perfectly balanced, it will give me a true, otherwise it will give me a false. And then I will defining the value function name with check, and I am taking the parameter as input string. Okay, now what I have to do here, so I have to create an stack first. So how should I create? I will create a stack array, and I will take name with stack and then stack array. Okay, so what actually we are doing here, we are first in earlier when we created the function class name is stack array. So since both this Java function are kept under the same folder, I can access the stack array as well. So I'm creating an object of stack array directly, and using I'm going to use stack function directly to solve this balance parenthesis problem. Okay, so that is the first time. Now second thing that I have to do, since I have given this as a string format, I have to make it as a char array. So what I will do is, because such that we can analyze each and every character one by one, and we can put each and every character based on its requirement to the stack. So I will just make it char array, and I will just put input str to array. Okay, to char array. Okay, so this is an inbuilt function which convert string to char array. Okay, I'm just putting it out like that. Now I'm going to iterate to each and every character given in the string, and see that whether and wherever the problem will be there, I will put that in the wherever the opening braces will be there or opening brackets will be there, I will put that in the stack. If the closing braces will come or brackets will come, I will just pop it at one element to check whether it's present or not. Okay, so now for element, I will say int I equal to 0, I less than char array length, and I plus plus. So for identify any array, we can use char array as the array name plus dot length as functionality to calculate its total length. Okay, so that we don't have to calculate and write a separate function for that. So now what I have to do is, I have to take out each element one by one. So what I am doing, since it is at ith position, I will take the element, the character in the current variable, which is present in the ith position of the char array. Okay, now I just have to check, I have to put some if else formula. That means if wherever the braces are open, so brackets are open, that is if current like this, or just copy paste few things. Okay, if there's an opening curly braces, if it's an opening square braces, or if it's an opening parenthesis, what I have to do is, I will put stack dot push the current value. So I'm creating an object for the for this, and I'm pushing the current char, which is I defined here, that is the ith position of char array. And if it is any of these characters, 3 of these characters, I will push that in the stack, just like how we have seen in this when we say element dot push 10. So instead of integer value, I am pushing it as a character there. Okay, so that's a difference. So if I enter the character, I just need to continue. So using the continue as a statement, what it will do, that it will skip the rest of the remaining statement that we are going to write, and it will go to the next pointer, that is I plus plus. It will do the I plus plus and it will go for the next character. Okay, so now that is one thing. This is for first thing, that we are assuming that given a string, some characters are there. So what if the character I put the empty string there? So what I have to check that. So I have to see that if stack is empty. So by default the stack will be empty, and if I put any string with no value, it should return this what you say, it should return that the stack is empty or false, something like that. Okay, so I have to return false here. Now this is one thing. Now we have identified that wherever the starting opening braces or opening brackets, we can identify that and post into stack. Now we come back to second part of the question, where we have to see the closing, wherever if we are able to find some closing square bracket or parenthesis, so how to deal with them. So either we can use the same way, we can use if and else, but I am going to use here switch case for to give a different approach here, because we can use the same if else case in that scenario as well, but I thought of let's take a different route and use switch case. So what I have to do is I will taking a one temporary variable popchar. So whenever we encounter any closing brackets, so at that point in time we are asking the stack to pop out the top element. So that top element will be, we will storing that in popchar, storing the top element recently popped out in this temp variable. Okay, so I will use a switch case here, where I am passing the value of current and I am giving a case here. So the case is if I get a closing parenthesis. If I get a closing parenthesis, so I should tell popchar, and I am taking stack dot pop, stack dot pop. If I do that, and that means I am taking whatever the value that I put there in stack, I am putting that in a popchar as a temporary variable. Then I am going to check, instead of checking the whether they are similar, whether instead of checking like whether this or not, I will do a different thing. What I will do, I will check that whether it is equivalent to the opening curly braces or opening square bracket or not. That means if I will do popchar is equal to opening braces. I can do the other way also. I just write here and then I can do the work. That is one way is fine. Otherwise, what I can do is I will take out the, I will see the whether the popchar, the pop down element is similar to any of these characters. If any of these characters are, if they are similar, I just need to return false. Okay, so after this, if I do this, and then after I have to break, if you remember the switch case, I have to break the statement eventually. For every case I have to break it. So similarly I copy and do for other remaining two cases as well. Just change it. Okay, so I will do for if it is a closing square scrolling square bracket, at that point I have to check whether the popchar is if it is equal to opening of curly braces or opening of parenthesis, I should return false, otherwise it will be true. Okay, how we usually see it, we directly try to make if else condition directly, so we don't think in terms of what if we don't put else condition as a if, so I am doing the reverse here. So I just have to see that if popchar is the whatever the element popped out, if it is opening parenthesis or close or opening square bracket, I should return false, otherwise it will be working properly fine. Okay, if that is there, otherwise if switch cases also doesn't work, I just have to return stack. I just have to return this stack empty. Okay, so why I'm returning stack empty, I've checked whether it's stacking empty or not. Suppose all the for loop is been done. Okay, I have to take it out of for loop. Okay, so if the stack is not, if the for loop is done, but I'm not able to find the proper balance between the parentheses, at that point I will say that it's not balanced. Okay, so again to repeat, okay, I will share the code. I will give out the link in the. I will share the YouTube this video in the YouTube. In that as a description link, I will share the code. Okay. Okay. So what we have done is, I just to identify what we have done. Just to summarize is, so there is a problem of parenthesis. Okay, just like this, highlighted one on line number 8. So you open with certain brackets, and in between, if you put any other type, the different type of brackets are there: curly braces, square brackets, and parentheses, and it should be in proper order. If they are not proper order, we are telling them it's not balanced. If it is proper order, we are saying it is balanced. So we using the stack, we are trying to create the instance where we can find whether it's balanced or not. So what we are using, stack basically. So whenever in line number 25, whenever we see an opening brackets or curly braces or square bracket or parenthesis, we are pushing that into the stack. And whenever we see any closing instances of parenthesis, square bracket, curly braces, then we are checking that. Then what we are doing, we are popping out one element from the top of the stack, and then we are seeing that whether the element is equivalent to the opening of that closing parenthesis or not. Okay, just like we have done, and then we are returning the value. So let's say it works or not. So in this line 60, we have given this string input stack, which is a balanced case. Right now we will see the imbalanced case as well. So according to this, string is balanced. So what if we do certain changes in this input string, and then I will create it little bit imbalance. Okay, so what I have done, in the same string I have added that a square bracket in between, and then as a opening, and the closing it is a curly braces. So ideally it is not balanced. Whether it can identify or not, let's see. Okay, so it is able to identify that it's not balanced. Okay, so another aspect that two important things that we have done here is, we are using an already created class called stack array, which we have created in the first session, which consists of all the basic operations of stack. And you don't need to create every function and variable into the public class. You can create a class separately which is not public. You can use it, and you can use the same class in some other functions as well. Okay, so that is another aspect that you have to remember if you're looking at this session. Okay, and when I'm not using also public, I'm directly accessing a file which is not a public class. It's not even private. If it is private, I can't access it, but still it's a default class there. I can access them and use them in a balanced parenthesis problem to solve a particular question. Okay, so that's the three aspects that we have discussed today. So the three aspects that we discussed today is, first we have discussed what is stack. So this is, first we discussed stack, how to implement stack using array. Okay, how to use already created stack class to solve a problem which uses stack as a base. Okay, so these three aspects that we have used. The problems, I know that they might be simple or many people might know it, but many people might not see it from this angle. Mostly people do, they write everything in a single code without differentiating. Otherwise, if I write it's a 70 line of code or 50 lines of code that we have written in this parenthesis, and in this stack implementation we have wrote approx 70-80 lines of code. If I put balance parenthesis class here in this stack implementation, it will become very hard because it will become 200 lines of code, which is for you it will be very hard to understand. So you have to divide the class in a certain way to properly understand where the segregation you should do, where the segregation you should not do. So that aspect should be clear. Right now I have created every function as public, but that's not a rule. I can make certain functions private as well. So you keep on try this stuff over the period of time to check where I can use public, where I can use private. Okay, which is used to evaluate infix expression, stack or trees. Usually stacks are generally preferred ones to use infix expression, because if you know the concept time complexity, it is quite fast if you use stack. That is one thing that we can use. Okay, another question is, if we implement stack using lineages, then what will be the time complexity of question pop operation? Okay, I think it will be in the order of n, not more than that, because okay, so if people don't know what is linked list, it's another data structure that we can use over the period of time, where it is not stored in a linear fashion. You can use the pointer in different ways at different places. You can store them in a different places in the memory. So the time complexity for that will be order of n. Okay, so I think it's almost 7. So what I'm going to do, I'm going to stop the recording.